What allows species of different Australian insects to have a higher survival rate? The first insect I chose was the dragonfly. The reason I chose the dragonfly was because it occurs in a wide range of habitats, including rainforests throughout the world. Another reason I chose dragonflies was how they fly. Dragonflies have 4 ways of flight: counter-stroking, phase-stroking, synchronized stroking, and gliding. Synchronized stroking is where it uses all 4 wings to propel itself in the direction it wants to go. Phase-stroking is where it uses its front wings to propel itself. And counter-stroking is where it uses its back wings to propel itself. Another reason I chose the dragonfly was because of their speed. They can move from 19 to 38 miles per hour. The last thing I have about the dragonfly would be how to identify it between a damselfly and a dragonfly. A damselfly, when it is resting, will have its wings closed, unlike the dragonfly, which will have them rested open. And a dragonfly's body is more long and slender. The second insect is the stag beetle. It is named after its horns, which resemble the antlers of a stag. It uses its horns to fight for a mate, and it uses for protection. Another reason for its high survival rate is because of its shell. Its shell is split into 3 parts for better mobility, and so it can slide over, so its wings can pop out for flight if it needs to flee. If you look at its horns, they are elongated and they should not be able to have much force. But in the beetle's skull and head area, it has input levers which increases the amount of force it can bite down using its horns. The second beetle I chose was the rhinoceros beetle. It is known for its giant horn in the front and its tremendous size. The reasons for its survival rate is its strong shell, which protects, and it hides itself in the night and protects it underneath heavy rubble. The horn is used to scare off larger prey and is used to fight for a mate. The reason I added the cicada into the list is because the cicada burrows underground for 7 to 13 years at a time. The cicada eats roots, and the only time it burrows to the surface is to mate. And the coolest thing about a cicada is only the males can sing to attract a mate. The next is an arachnid. It is known as a giant water spider. It sits at the surface of the water and is light enough and disperses its weight over the water and algae around it to stay on the surface of the water, and it preys on smaller fish. One reason its survival rate is because of its large size. It is big as a hand, and its mobility on water and land. The next insect I chose was the praying mantis. Its survival rate is higher because of its camouflage and its claws, and how the praying mantis can move its limbs faster than the muscles can contract to capture their prey. The praying mantis feasts on almost anything, but it mostly goes for anything that comes near it, and it tackles its prey and takes it down. The second to last is another arachnid. It is known as the huntsman spider. It is different than most other spiders because it does not use any webs, and it literally hunts down its prey by chasing it and taking it down. Another way for the huntsman spider to gain its food is sit and wait for prey. Because of its camouflage, it can merge into its background of a bark on a tree. Another reason for the huntsman spider to have a higher survival rate is because it has adapted to living with humans quite well. and that is why it is known to be seen in walls, inside toilets, and local areas. Another feature would be its size and its speed. Some of them can be 16 centimeters, but they're actually harmless to humans. The last insect is the paper wasp. The reason the paper wasp has a higher survival rate is because it travels in packs, and because of its size. Its size can be around 1 inch long, and it has its own weapon. The way its weapon works, it first injects venom into the bloodstream. The venom breaks down cell membranes. In the venom is also a neuropinephrine, which slows down blood flow, which makes it last longer. Venom makes its way to destroy membrane by melting through connective tissue, which is what makes you feel the pain. The end.